Okay, I know this isn't what you were expecting, and I think you can hear me. Okay, let me just check one thing. Yep, okay, looks like the microphone's working. So this isn't exactly how we do it, so we're gonna roll with it, and hopefully you can see everything. So this is gonna cover what we're gonna do today, and then also what I expect of you Monday, Tuesday, and Wednesday of next week. As I'm not going to be here, we're not gonna meet, but there are assignments and things for you to do. So to pick up, this is going to take a second because this is a kind of making it work situation. Let's see, where are we here? Okay, so we need this guy right here. So we're going to pick up where we were yesterday. Independent, the different types of lines, and hopefully this loads. I had everything else ready other than this one. So, of course, it's probably up there somewhere. No, it's already up there. I lied. All right, so it's all set. There we go. Present, and here we go. So, we were talking about all this, recapping. These are drawings, 3D or axiometric projection, and a 3-view orthographic. Orthographic being those two-dimensional views of the top right side and front, or back or bottom, depending on what's necessary for that exact project. We talked about zoomed-in views and a few other things. As I said, I'm going to post this video. If you have questions, I will be a little bit I'm always a little bit out of touch, but I won't be as easily accessed as I have been. I know some of you are kind of worried about where no, actually, you guys are all fine. I had a few other emails, sorry. And I'll, if you are worried about where you are, shoot me an email and let me know. So we talked about orthographic projections. All this stuff should look familiar. You have a three-dimensional object which you're going to create. And this doesn't just mean a solid object. We've been looking at solid objects, but it can be a bookshelf, it can be a chair, it can be, so like if you think about it, pretty much anything other than something that's like carved or machined out of a solid piece has multiple parts. So technically they're an assembly. We talked about parts versus assembly, and you could draw each individual one of these things out. If you're building like an Adirondack chair, yes, that detail is good. However, if you're doing something like that, what you run into is that it becomes all these like kind of needless drawings when you can say a piece that's 6 inches wide, 3 inches tall, and is 6 inches wide, 3 inches tall, and has a thickness of 3/4 of an inch. I kind of screwed up a little bit on how I said that, but like it's like a piece this big, like roughly 3/4 of an inch wide, and with stuff like that, what you need to have in your mind is, I can just tell you what that is, because it's a raw material cut to a length normally, or something that's slightly adjusted. I don't really need a print. If I've got something that's a lot more complicated, like it has an arced piece, and there's a detail here, and I might want a drawing for that. A lot of times you'll find you'll get a assembly drawing, or a couple different views if with something like a piece of furniture or whatnot. So anyway, here we go. So you see, we've talked about all this. Where we stopped, talked about axiometric projection, special views, using the working drawing in the shop. We looked at this. We're actually going to spend a little bit more time on the. Actually, let me just say this now, and then we're going to come back to it when we talk about what your assignments are going to be for next week. So if you look at this is point K, this is point D. This line, in terms of how we're going to look at it, because what I'm trying to get you to do is not just think about, okay, this is a print, this is a drawing, I'm going to make something out of it, boring, boring, boring. I'm trying to get you to think how those views work together. And that's what the worksheets are going to do. You've got 2 worksheets in measuring and 2 worksheets in drawing. They will take you a little bit of time. 2 of them are pretty quick. 3 of them, the measuring one shouldn't take you that long. and I'll explain those in a minute. The first print reading one, only one of the assignments really should baffle you and make you want to do it a couple times, but we'll talk about that in a little bit. But again, back to this. This is the close point to me, K, and that's the far point in this view, and that's D. So this line is representing KD. Same thing, A, B. A is close, B is far away. That'll become important because it's going to be how we link the different drawings to really use them. So we'll get back to that again. Another thing. Finding dimensions, we talked about this. This is where we ended yesterday, types of lines. And we kind of rushed through this. We talked about, was it this or was it this? And, wait, were you able to see that? It's a little bit whited out, but that's okay. So this is the two cubes. This is the two cylinders. Why do we go from this drawing right here and realize that it's actually the cylinders? You start looking for things like center lines. And the reason for that is because those center lines dictate that there's some type of circle. These hidden lines mean there's some type of edge, not edge exactly, but that there's something contained within that. There's a feature. And in this case, since we have a center line that normally says circle, because with a circle, we are either talking about the radius or the diameter, the radius or the diameter. I was saying the opposite that I was pointing at. So radius from the center to the outside, the diameter across through the center point. So that's what keyed me in, that it was this guy versus this one, and that's those hidden lines basically mean that there's something cut out. It's not always a cutout. There's a feature that you cannot see. It could just be that the thing steps down internally, and what I mean by that, like, is if it was like something like this from the top. Can you still see that? Yeah, right here is better. So if it was like this. No, it's not the best drawing, but actually it should be more like that. So like you'd still end up with a hidden line right. You could still end up with a hidden line right there. So it does tend to be that there's something removed. So it's a little confusing, but I didn't want you just to think it always means that there's a drilled hole. It doesn't necessarily mean that. So we have our dimension lines. So these extension lines right here are saying this edge or this edge. They always reference an edge or at least a space within something, because it doesn't have to be an edge. It could be essentially a line delineating how far over something is. So like this center line, I could measure from this edge to this center line, and I would technically still use an extension line. So that's just, I want you to, again, it's the special, not special cases, but most of the time it's an edge to an edge, or an edge. Yeah, it's normally that. There are times when it gets a little finicky, but what I'm doing is I'm saying if I took a tape measure and laid it right here and measured to right here, it's 2 inches. Same thing here, from here to here is 1.25 inches. All right, we talked about center lines, we talked about hidden lines. You can see the difference between the hidden line and the center line. Uninterrupted, just dashed line consistently all the way across. The center line extends beyond and has just a dash in the middle. So we talked about extension, dimension, hidden lines. This cutting plane. So if I wanted to, we talked about that zoomed in view. If I wanted to create another zoomed in view, but I wanted to do it in the center of this thing, let's say I wanted to actually, let's get rid of this. I think you can see this area. It's not glaring too much. So this from the back, if I had that cutting plane where it is, and I wanted to do and this is actually trying to go off that a little bit more. It looks something like that. Not exactly, but something like that, in essence. What I've done here, and like probably have a little bit of a hidden line right here, right here. Yeah, something along that. And this is going off of the drawing more. These are just a facsimile, they're missing pieces. I'm not that good at drawing 3 dimensions. But anyway, so what we're looking at here is that we actually cut the drawing there, because there might be some feature in here that we have to machine out, or there's some information we need. And what that allows us to do is really get in there, and we essentially get rid of part of the drawing or the representation so that we can see that detail. So that's why that's there. So we talked about hidden lines, cutting planes. The object line is the actual line that creates the object. It's a solid line. You'll always see it's continuous. It's not broken unless it's like it will always be normally it's some type of solid line. What I do is I start thinking about, there might be some weird instance where something is, and then that gets confusing. So we'll skip that. All right, we talked about object lines, hidden lines. It said center and extension lines. We talked about them. Just looking at this, the center of a radius, circle, or cylinder is marked by a center line. So as I said, that's what keyed me into this. Excuse me, in this instead of this. Okay. Let's see if this helps. A cutting plane is used when it is necessary to show the inside feature of an object. Oh, also, like this was a cast object, meaning that you poured some type of liquid that then solidified. The engine block in the vehicles that most of us drive they're cast, but they have internal passages. So there's an added layer of complexity, and you need to know how to form that cast. And we can talk about that at a later date if any of you are interested in how that works. Okay, there's my pointer. Section leader lines, we talked about that. Drawing mate. Oh, scale is important. So if we have, and we can get rid of these guys now. You do. Okay. Scale. So 1 inch equals 1 inch. So if I have an inch in real life on my piece of paper, it is an inch. If I go the other way, I can represent it 2 different ways. I could do 1/2 of an inch on my paper equals 1 inch, or 1 inch on my paper equals 1 foot, and so there are different scales. Or I could do 1 inch on my paper equals 100 feet. You can do it, like, it doesn't always have to be 1 inch. It could be 1/2 inch equals 100 feet. It depends on what you're doing and what an appropriate scale is. Most of the stuff we do, you'll probably be somewhere in here, like 1 inch equals a foot, or 6 inches. Like, it depends on how big the thing is, and also how big the piece of paper is. So scale basically is allowing you to represent something larger in a smaller area while still maintaining the aspect ratio, meaning that your whatever you're building or whatever you're representing it's the same. Like it's 3 inches on the 3 inches vertically and 3 inches horizontally. Even if it's 3 feet, they're still the same. So it's not like it doesn't get distorted. Okay. Yes. Oh, you can go the other way too. So if it's something really small, so you do 1 inch equals 0.1 inches. Title block is basically the information for the drawing. Drawing number. So the program I use primarily is called SolidWorks. You spend $5,000. You can spend between a student version's a couple $100. The full version's like $2,000 to $5,000 dollars. It's a super powerful platform. I don't know if they've improved this, but as of 5 years ago, you'd put information in and then it would fail to put it in the right place in the title block, which was really hilarious. Because you're like, well, I can draw and 3D print a spaceship with this thing, and it can't put the title in the right place. That's great. So it's kind of funny. But otherwise, it's a great program. And that also helps you keep organized. We're not really worried about that right now because we're not building anything really big. All right, there we go. Come on. Is that the last slide? No. Yeah, that's it. All right, so what's this do? All right, so what we're going to do, I thought there was one more after that, but I guess there's not. So what we're going to do is, here are the two print reading exercises that you're going to do. The first one is just orthographic projections. So you're going from an axiometric or 3D view to those 3-view orthographic projections. So what each letter here, you can see my pointer. I'm pointing at, let's just do the face here. So I'm going to basically give you the first one. There's only 7 of these. So it's not like it's going to be a whole bunch of time. Actually, I can't even see it from where I am, so it's not going to be super helpful because I won't be able to tell you that. But this one right here, so we look at it, we think about what that view would be. So we have this one, and then we'd have this little piece right here. That's normally going to be, I believe this says front view. As I said, it's a little hard to see. This video is put together pretty quick to try to, get things going. It's probably going to be about a 20 or 30 minute video all in all, but I'm trying to get it together after our internet issues this morning. So I look at this, A. You see this title block here, A. What you're doing is you're going to select 1, 2, 3, 4, 5, but A is our front view right here, and then you can see A, I think that's E? I said, I really can't see it from where I am. Maybe that's C. Whatever it is, it's this view. You're trying to match A to whatever this view is. I believe that's 3, so A would be 3. Then you do the rest of them. All the same print. I'm not pulling any tricks on you. I believe this one's just multiple choice, so it's real simple, real easy. And we're done. Okay. Rule reading. Oh no, sorry. Let's not do that one yet. Print reading. This is the second one. This is the hardest one out of all of them. And we'll do the first one together, just like we're doing this, and then I'll show you the rest of the activities. All right, so I might have to walk forward to see it a little bit better because it's small on my screen, so I assume it's going to be small on yours. But you can open up the real Google form. This is all in Google Classroom. Again, all in Google Classroom. This is print reading, I believe, 1. And then, so I think this is print reading 1. The other one's print reading 2. And do those 2. You can try them today if you want. Or wait till Monday, Tuesday, and Wednesday. As I said, there are 4 assignments. 3 of them should be relatively quick. This one's is probably going to get most of you. You can do it as many times as you want. I would recommend in between those coming up with a few well-formulated questions and emailing me, and I'll try to get back to you. All right, so in this, I stopped and specifically talked about in the presentation how a line is represented. I think this is how this looks from this side. Let me look at it again. Yeah, okay. So this point and number 1 is 1, comma, J. So that means so in the first problem, what we're doing is we're looking for what 1 is. What letter would represent it so we can represent that entire line. We don't have we have to search for the rest of that information. Is that 1? It is 1J. Let me just make sure I'm reading that right. Yeah, wait. No, I did that wrong. This is the wrong view. That was IJ. 1 is up here. Sorry, as I said, this is not what my plan was. I can't see things well because of the way I did this, because of the way this is put together. I'm sorry. So it's 1I. Then our other view, which I had up there, this is, wait, hold on. I lied. Again, so this is 1L, this is I, comma, J. Okay, there we go. That's right. I apologize, I just stumbled over that. This is 1, which is what we're looking for. This is our question mark. This point is IJ. So what we're looking for here, so 1 is close, and then if you go all the way into the board, so if you had your 3D representation of that, so this is the 1L. This line is L is here, and 1 is up here, L is down here. So it's that whole line. That's what this was if it was 3-dimensional. Okay? Here we have I, which is the close point here. We are looking for, so the close point here is I, the far point is J. This is this view, this is the top view. This right here is this point here going across. As I said, I'm sorry I've stumbled over some of this. I really apologize. But I'm trying to, as I said, this isn't how I wanted to do this. I wanted to interact with you guys. I really apologize. So close point is I. Far point is J. That means that 1, which would be our close point here, 1 is J. I hope that makes sense. What we're trying to do is we're trying to look at these lines, and we're naming the lines. As you go through, you'll gain more information, and you'll be able to name more of them. That's the first, I think, 10 problems. 9 or 10 problems are all like that. So the answer to the first one is J. So I is close, J is far. As long as I read the thing right, because I can't really see it from where I am. And that's why I had to go over there. So I apologize again for that. So you'll do the first, I think, as I said, 9. I think it's 9 problems like that. 10, it changes a little bit. It asks what this line is right here. And then we move into measurements. Okay, with this, what you are doing is you are measuring in between the lines. So if I have a dimension line that's right here, and I need to figure out what it is, that's what I'm looking for. If I know, let's see, normally they won't do that, something like that. So if I know that, so this is the front view. So if I know that the front of this measures 3 inches, I'm just saying this, I'm not actually looking at it. If I know that the front of that is 3 inches, or I know that, let's say, this to here is 1, here to here is 1, this thing is symmetrical, I can figure out that 1 plus 1, this would also be 1, because even though it's not marked, I know that if this thing is symmetrical across this axis, that this is still 1, and then that also should be 1. I can figure out that that's 3. If I know that's 3, or I know this is 3, I can then, because this isn't tapered, I can see that.
Attention please. If you have any Excel or Word documents open on your Windows laptops or desktops, please save all changes right now. We will be rebooting the file server at 10:32 a.m. Thank you.
See, it's just like being in school. Just kidding. So I know that this is 3, so I'm going to either a different part of this main view, so this view here, I might need to look down here, or this view here, I might need to look up here. Whatever view I need to look at, I can get the information to figure out the rest of it. I hope that makes sense. And it doesn't have to be something wide like that. It could be how big is this piece right here, if I know this, and how wide it is. Can you see when I do that? Yes, okay. Okay, so what I'm doing is I'm figuring out, so like one of these numbers, it's multiple choice. So you should be able to, even if you're a little bit confused right off, what you can do is you can take what you know and use it to figure out what you don't know. Okay? So that's that. And then there are a couple, like, you know, ask you, there's like 7 or 8 of those, I think. And then it asks you, like, what type of views are this? What types of views are these? What are these views? So like top, bottom, whatever. I recommend you write down your answers because you might be like, oh man, like, oh, I got 25 out of, I think it's 30 points or something like that. I got 25 out of 30. Oh, and it'll tell you which ones you get wrong. It's like, oh, I thought that one was A, it's really B. So, yeah. So some of these are questions about, there's so many of those. Oh, I guess there are more of those than I thought. And there are just a couple, like, which type of axiometric view shows angles and corners are equal sides. So you can go back to the presentation, which is posted on the Google Classroom. Okay, so last thing. So that's your 2 print reading worksheets. So you can do those today, Monday, Tuesday. I don't care which one you do. All right, so this is, what I want to do is get rid of this. Okay, so we're at the point where I want to just, these 2 should go really quick. But what I want you to do is we're going back to the inch. Normally this lesson is, what did I do with my tape measure? Oh, I was measuring where my refrigerator goes in the classroom. I've been cleaning. So, where art thou? Okay, we'll just use this yardstick. Actually, trick question. This is not a yardstick. I might have done this with you guys. I think I've done it with the other classes. This is actually, no, this one is a yardstick. So yard, 36 inches, meter stick, 100 centimeters, or I think it's like 39.25 inches. So you can see you can't see the difference. So there, you can see the difference. They're about 3 inches different. Yardsticks and meter sticks are different. Okay. So we're going back to the inch. So the inch, 1 inch goes into a foot 12 times. 12 inches in a foot. 3 feet in a yard, we're not really concerned about yards. We're going back to the inch because I want to make sure you feel comfortable with fractions because you're going to be using fractions a lot. Or in the case of SketchUp, when we get there, you'll be using fractions or decimals. All right, so 1 inch. There are 16 sixteenths in 1 inch. But before we get to those 16 sixteenths, let's just divide this thing up by dividing all of our spaces in half. So we have half an inch, which is if you take the total of an inch, put 1 line in it, you end up with 2 halves. It's always looking at parts of the whole. Then I take my halves, I divide those in half, I end up with quarters. I take those again, divide them in half, so that's 3/4 of an inch actually. So if you look, 1, 2, 3, 4, there are 4 quarters in a whole, 3/4 is right there. Divide those again, I end up with eighths. I'm getting a little smaller here, so I make sure I can. So that's 1/8. This would be 2/8. 3/8. 4/8 is the same as a half. 5/8. 6/8 is the same as 3/4, and 7/8. Okay? We divide one more time. That's when we get to 16ths. The reason we do this is not because I like making your lives difficult with fractions. The majority of people look at fractions and they want to leave the room. The reason we do this is because if you're measuring something and you only have, let's say, inches to use, what's going to happen is you're going to be like, oh, it's 13 inches and a little bit. Well, that little bit can vary between that little bit and that little bit. You can see that from where you're sitting and through the miracle of technology and the YouTubes. Thank you, the Googles. Anyway, this is so we can become more precise and accurate, which we won't get into, but precision and accuracy are two annoying concepts that if you ever do chemistry, you'll learn to hate. But anyway, so 1/16, and we can get smaller. We can get a lot smaller. We can talk about thousandths of an inch, which is really, really tiny, but it can really cause a lot of variation in certain mechanisms. Watches, for instance. Okay, so we have 16/16. I'm not going to spend a lot of time on this because my assumption is that most of you have sat through this class in math. This is a check-in. But that doesn't mean if you feel like you haven't mastered it, don't just move on. Let's work on it. Send me an email. We can talk on the phone. We can set up a small study group. We check in on this because it is so important with what we do here. Stuff that's crooked binds. And if it doesn't bind, it can break, or it doesn't go together right, or it hurts when you run your finger into it. So what we want to do is, this is 1 inch. We divide it up into 16ths. One of the things we're going to do is, so 5/8, or actually let's do this. Let's look at 5/8 compared to 9/16. Okay. 9/16 and 5/8. And let's throw up 3/4 as well. So if I were to go to eighths with 3/4, I would have 6/8. If I go from 6/8 to 16ths, we're looking at 12/16. Okay? The reason why I'm showing you this, I know this is kind of a weird, what we're always looking for is we're looking for the simplest terms, or lowest form. So what we want to do is we have 12/16, or even if we go to like 32nds or 64ths, we start looking for what's called the lowest common multiple, which is the thing that will go both into the numerator and denominator. We're not dividing the fraction into smaller pieces. What we're doing is we are just basically taking these little pieces. So if it's like we said, 3/4, if you count all those 16ths, basically what we're doing is trying to create even chunks. So if we counted all the 16ths over and we wanted even chunks, we take the 16ths and chunk them in the quarters. We get rid of that, and we end up with 3/4. So 12/16, if you just divide the top and bottom independently by 2, becomes 6/8 divided by 2 again. Over here, 9/16 and 5/8, we have an instance where we have, though these are not prime numbers, well, this one is, but that one's not. Wait, yes. Sorry, just want to make sure I was thinking about it right. Yes. We do not, there's nothing that we can find the least common multiple. We can't find something that will go into both of them. So we leave them. They are in their lowest form. The other thing is, if we have, are you able to see that? Oh yeah, okay. So let's say we have 1 and 3/16. That's how we want to write it. If that's how it is, that's cool. Lowest form, mixed number. Improper fractions, so this would be 19, did I do that right? Yeah, 19/16. That's how we get it. What we want to do is we want to go this way. We want to get to the 1 3/16. And the way we do that is there's 16/16 in 1. We see how many times 16 goes into here. So we go, okay, we got 1 because 16, and then we try to get to 19. So we've got 3 left over is the 3/16. I think I did that right. Yeah. 16, 17, 18, 19. Yeah. Yeah, I did it right. So you just want to make sure that you're in this form. When you answer the quiz, so let me show you the quiz. That's not it. Is that it? Okay. Do not write anything extra in the space below. If it's asking for one number, like it's asking for how many 16ths are in an inch, write 16. Don't write 16 question mark or 16 I like tacos. Just write 16. If it's a fraction, what you want to do is you want to write 1 slash, if it's asking for half, 1/2. If it's a mixed number, it will accept 1, no space, 1/2, 1 space, 1/2, or 1 dash, 1/2. I went through because it was a little bit funky. I put dashes like this in between when there are mixed numbers. Can you see that? Yes. 1-2. So that means 1 and 1/2. It was just to give you the separation so you could actually see it. All right, so we're about 36 minutes here. I lied. So we're a little bit over. So that's our first one. Our next one is, that's not what I wanted. That's what I wanted. Our next one is, so like this is a whole presentation. I only put the truncated version, I think, on the web page, on the Google Classroom. This one is a rule reading exercise. What you're doing is you're going in and looking at, so the first 1, 2, 3, 4, all starting at 0, and you're trying to figure out, in lowest terms, what they're showing. So like if it's at 5/8, write 5/8. Same way, same format. I think there's 16 questions on each one of these. Lowest terms, mixed numbers. You writing it like this may or may not work out well for you, but I'm looking for this. These ones, so like we start getting into here, we're not measuring from 0, we're measuring between. So if you start at 1/4 and you measure to 2, that's 3/4. That's not 1 and whatever. So like, I think this is I or L, I can't read it from where I'm at. But, so it looks like you're starting around 1 1/4. You start there, you measure there. Easy way to do this is you take your first point, you take your second point, you subtract the second point, you subtract the first point from the second point. Same thing here. So it's not starting at 0, like P starts at 2, goes all the way up into here. You're measuring the whole thing, okay? One weird thing here, K, is between these two lines. There are arrows on the outside. So do that. The Google form looks like, there it is. Same thing. It's a little bit better, I think, in this way. So it's a free entry. So you write it, but it's, I think you just saw the answer. Current answer. So you look at that one, you got the answer. So you're welcome. Everyone should get at least one right. Do all those. So those are your 4 assignments. Orthographic projection, fraction, print reading, and rule reading. They should return whether or not you got them right and what your score is right at the end. Do them as many times. I think I have them set up so that you're able to do them as many times as you want. And I believe they automatically upload. I think I fixed all the bugs, so now that's it. Those are your 4 assignments for Monday, Tuesday, and Wednesday of next week. So that's everything. If you have questions, email me, and that's it. See you later.